I know Jean's week. Somebody needs to share that list with him, since I failed to record class up to this point. I'm recording it now, but one of you guys be a friend and share that list with him, because he's going to come in here Monday morning and take his exam, and we want him to make sure he knows what to study this weekend too. Will y'all see him at school today at all? Okay, cool. All right, let's see here. Now, you might not, because of the lighting in here, you might not be able to see the blue arrows, but what we've had going on thus far is, like with FOIL, you're multiplying a by times a by, you move it to the left over there on that screen. What we're going to do today is we're going to practice moving from right to left. We're going to move from that trinomial, and we're going to express our answer as a by times a by. It's the reverse of FOIL, F-O-I-L, first, outer, inner, last. And so what we're going to do is we're going to talk about how to express a trinomial as a product of two binomials, okay? I think you guys will do well with this lesson. Here are our first three examples, okay? Now, this will be a me, we, you, okay? I'll do the first one, we will do the second one, and then you will do the third one. Y'all write all three of them down here. And what we're going to focus on is our ability, Quentin, to put together a list of factor pairs, okay? My son, Teddy, is 9, he's in the 4th grade, and they do like this thing called case testing. It's kind of like TCAP or whatever standardized testing kids used to do when you were younger. And so we got some results back from him, and he typically is not super strong in math, but he's been working really hard this year, and so he got some good scores on his math. But one of the things he needs to improve on is expressing a number as a pair of factors, in other words. So that's a skill that we start learning in 3rd and 4th grade. You guys have been doing this for a while. So when I say writing out factor pairs, I'm going to start with this first example here. And again, I'm going to look at the number 24. And what I want to do is I want to come up with an exhaustive or a full list of factor pairs for the number 24. I'll start with 1 always, and I'll work my way down the list. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. It doesn't divide 5. 6 times 4, but 6 is already on the list. So I've done what I call turning the corner. I've turned the corner. I've now gotten my list completed. Okay. Now, what I want to do is I want to pick the pair of factors that adds up to give me this linear coefficient. Can you pick the pair of factors? I know I can. I'm going to pick 3 and 8, because 3 and 8 is going to give me 11 when I add them up. You might say, well, why the dump are you adding them up? Check this out. What we're going to have is the template of our answers, a binomial times a binomial. And remember how we're unfoiling this? We're doing FOIL in reverse. Well, remember, F stands for first. So if I'm going to multiply the first times the first, that's what's going to give me this x squared over here, okay? And so there's no possible way for me to split up x squared other than x times x. No logical reason why I would split it up as 1 times x squared. That's kind of silly. It's always going to be x times x. So I know the first, and then again 24, I know the last times the last is going to have to equal 24, hence the factor pairs of 24. I know whatever I put at the back side of each of my binomials is going to have to multiply to give me 24. So like there's 4 possible ways I could write this up. I could say x plus 1, x plus 24, x plus 2, x plus 12, x plus 3, x plus 8, or x plus 4 and x plus 6. Okay? In other words, I could use any of those factor pairs. The reason that I'm going to pick 3 and 8 has to do with the outer and the inner. Right? This is where the oi comes about. So what I want is I want the pair that adds up to equal that middle linear term, so that when I do my FOIL to check my answer, the outer is 8x, the inner is 3x, 8x and 3x add up to equal 11x. Okay? And did you note that's how we always check our answer? Just FOIL it back out. Okay? This is a very simple factoring technique. We like this factoring technique for these, regular trinomials. It's very, very straightforward. Let's see if we can do one together now, okay? Here's our next example. We know it's going to be a binomial times a binomial. Tiago, what's going to be at the first term of each of those binomials? What's going to go right here and right here? Remember, the first times the first is going to be how I get my y squared. Yeah, so it's just going to be y. And we can go ahead and take that and assume, you know, that that's what it's going to be. And then for my last terms in each binomial, I'm going to look at 28, aren't I? And I want a list of factors. George, help me with my list of factors. Start with 1. 1 times what? 1 times 28. 2 times 14. 4 times 7. And that's all she wrote. 5 doesn't go in, 6 doesn't go in, 7 goes in, but we've already used it. Turn to the corner. Now, I want the pair that adds up to 16. Okay, Andrew, what pair is that? 2 and 14. All right, so I'm going to have a 2 and I'm going to have a 14. But notice I didn't put a plus sign in front of them. You know why? Because it's negative 16. Okay, because it's negative 16, I'm going to put a negative sign in front of both of those. Hey, let's write the following statement down. It's on the next slide, but I'll go ahead and let the cat out of the bag now. The sign of the linear coefficient right, will determine the signs of my factor pair. In other words, on that first example, 11x was positive, so I used positive 3 and positive 8. On the second example, 16 is negative, so I use negative 2 and negative 14. Charlie, how do I always check my work? I can FOIL it back out. Of course, the first times the first is going to give me y squared, and the last times the last, negative 2 times negative 14 is going to give me 28. That's how we got 2 and 14 to begin with. They were factors of 28. They multiplied to equal 28. And then the outer and the inner, when we multiply those together, we get negative 14y, negative 2y, and that adds up to negative 16y. You guys try this third one right here. And again, remember the template for it is going to be a binomial times a binomial. All right, and we ought to know what goes first in that slot, knowing that our first term over here, that quadratic term, is z squared. I'm going to get a little water. I'll be right back. Shouldn't take you guys much longer than that. Yes. All right. Drew Benton, what'd you get? Z plus 1 and z plus 30. Fabulous. Does anybody concur with that? I certainly do. Okay. Now, we picked a positive 1 and a positive 30 because that middle term was positive 31. James. Commutative property says that the order of factors in a product will not matter. So I'd take either one of these. All right. So the order of your factors does not matter in the least. Okay. Let's look at 3 more. Now, as I said, this was going to be on the next slide. You see it right there. The sign of our linear coefficient is going to dictate what kind of signs we have in our binomials. But you notice in these 3 examples, my constant term is negative. So in the previous 3 examples, it was either a plus times a plus or a minus times a minus. Here in these 3 examples, I know each one of them is going to be a plus and a minus. There's going to be a different sign because these constants are negative. And the last times the last is going to have to be a positive times a negative. You don't always have to put the positive one first, but I like to do that. And so there we go. Plus and a minus. All right, in fact, I'll just go ahead and put X, Y, and Z right there. We've done like zero work, and yet we've almost got the entire 3 problems already answered out, factored out. It's just that simple, okay? So again, I'll do a I'll do a me, we, you. Me, -8, I'm going to look at my factor pairs. Check this out. 1 times -8, 2 times -4, 4 times -2, 8 times -1. Okay? And I'm going to look for the pair that adds up to +2, and that's this pair. A +4 and a -2. And I can check my work with FOIL to make sure I get what I'm supposed to. Okay. All right, Luke, you want to help me with my 39? What are my factor pairs of 39 on this second example? 1 and 39. And so that means 13 and -3, 39 and -1. All right, and Mossy, which pair should I pick? Granted that I want a -10 as the result. Speak up. I didn't hear you. All right, what is 13 minus 3? What's 13 minus 3? 10. Do I want 10 or do I want -10? So change your pairing. Yeah, that a boy. We want that pair right there. We want 3 and -13 so that we can have a sum of -10. So it's y plus 3 and y minus 13. Again, the reason being, we know the first times the first. Y times y is y squared. That's cake. We're interested in the outer and the inner. When I multiply the outer, I get -13y. When I multiply the inner, I get +3y. -13 plus 3 is -10, and that's what I get there in that middle term. Okay? You guys do the last one. Y'all are rock stars. Do that last and see how you do. Have y'all gotten to this in y'all's classes yet, by the way? No? Okay. When you do, you're going to feel so good. When your teacher starts showing you factoring and you're like, oh, I already know how to factor. Yes. But it takes a lot of practice to master. It really does. It takes just buku practice. When we come back from Christmas break, I'll have a Kahoot with 20 of these on there. And by the time you're done with that, y'all do Kahoots? Okay. By the time you're done with that Kahoot, it will be, you'll just have it dead to rights. It's a drill it and kill it type skill, this thing is. All right, who wants to go through, who's got example 6? Do I see a hand? All right, Jack McBee, what do you get? 6 and -5. I love it. That's great. So we got 1 and -30, 2 and -15, 3 and -10, 5 and -6. I'll be lazy. I won't write the other 4 up because we could just switch their signs. Our goal was to get a +1. So this would have been 29. This would have been 13. This would have been 7. And this would have been 1. Haha, I want the 1. So I'm going to pick this pairing, just adjust their signs to make sure it's a +1. As opposed to a -1, okay? To factor something is to write it as a product. Very good. I won't give any homework to you guys, obviously, because you're going to be studying for your exam. But after Christmas, we'll be practicing a bunch of this, so keep your notes handy. And look, I'll see y'all Monday morning bright and early. Have a wonderful weekend. Live Jesus in our hearts. All right, and I appreciate y'all's work, fellas. Y'all be safe.